There we go.
All right. For this workshop, I have a deal with everyone. If you guys turn on your video, I will personally Venmo you 10 cents. If you turn on, yeah, so basically if you turn on your video, just so we can have a good interaction. So if you want, you know, free 10 cents, just like turn on your video, privately message me your Venmo handle, and I will do so after the workshop. I see we're chasing that bag.
Very nice.
I love it. Okay, let's see how many. Okay, we have 27. I think we can start.
I agree.
Okay. All right. So welcome everyone to the Introduction to PCB Design Workshop. If you didn't hear before, we would like you to check in using this link right here. And then the slides, if you want to follow along, is at this tiny URL. And then you need to download the Eagle software for the kind of like hands-on tutorial later on that we'll have at the end of the workshop. And so moving on, why do we need Eagle? Why do we need to learn PCB design? So you can go from a messy prototype on like your breadboard where there's just like kind of wires and components everywhere to a really sleek, organized, space efficient PCB board. It's a lot more compact. It saves wire. It's a lot easier to debug, easily repaired for like the different components. If it doesn't work, you just replace it. And it's basically immune to movement. So it's kind of like put into place with a PCB board, like your components, your resistors, your capacitors. Whereas when you have like a breadboard, if you like drop it, like all the components just like can fly out, and like you would have to rebuild like the circuit again, which won't happen when you have like a PCB. Moving on. So what exactly is Autodesk Eagle? We've been mentioning it since the beginning. It's basically a free PCB CAD software, at least for like beginners. And to basically create your own PCB, you have two different parts. The first one is your schematic layout. So that's where you're going to make all of your electrical connections between different components. And then you'll move on to your board design, your PCB board design, where you'll actually physically lay out and route different copper traces between the components. And so PCB design can be also like a resume protein powder booster to kind of beef it up. Like a lot of recruiters, they like to look at like this kind of skill for like PCB design. I know like Texas Instruments, one time they like grilled me on like PCB design when I was just like in ops. So I was like, I don't know this, but it is important. You can make your own personal projects with it. You're going to need it in like Micromouse, like AP, and I think a little bit later in ops, but it's just a really fun skill to have. So moving on to the next one. So once you've downloaded Eagle, you want to basically create a schematic. So that was like what I mentioned, the first part where you connect your components electrically. And so if you've never seen like what a schematic looks like, never really heard of what it is, it's just like a fancy word for saying a 2D graphical representation of a circuit. You'll see different symbols for each component. So as you can see right here, you have like a resistor, you have a switch, you have a battery, the diode, LED. And then connections, which are like your wires, are represented by lines. So you can see the positive terminal of this battery is connected to the top of R1, top of R1 is connected to R2, and so on. And so when you open up your schematic, you're going to see this kind of screen right here. And, oh, sorry, I was just looking at that. This is like your command line. It's an alternate alternative to like your toolbar that we'll go over right now. So the first icon in like your toolbar is the move. This is where you can move components like around in your viewing area. You can rotate components around, group components together so that you can drag them across like your window. And then to actually add a part, you want to click this icon right here. It kind of looks like it has like a plus on it. And we'll show you how to do that in a couple of slides and in our tutorial in the end. And then when you want to connect two parts together, so if you want to connect like an LED and a resistor, you need to use this kind of like net command or icon. And you basically route those two together. If you want to name like a resistor specifically like R1 or R2 or R3, you can do that with our name command. And then the next one is value. So for R1, you can put a value of 10K, 100K, 100 ohms, so on. And then you have another one called label. This is basically to label your nets. It will make your schematic a lot cleaner. That we'll see that a little bit later on. And it's just really helpful for like the eye visually. And then if you want to copy and paste components, you just have that right there. Delete a part, you just have this little trash can icon. And so some other common symbols that you might see in a schematic is right here. We won't be using like all of it today, but the most common ones that you'll probably see is like a battery, a capacitor, a resistor, potentiometer, like ground, switch, LED. You might see like op amps, transistors, and FETs like probably a little later on, but I would say these are like the most basic ones right here. And within your schematic, you need to pay attention to the polarity of like the LED, your capacitor or your battery. Like you can see right here, this is the positive terminal of your battery. This is the negative terminal of your battery, which is where your ground, all the ground should be connected to. For your capacitor, you might see like two different kinds of capacitors. One will be like a non-polarized one, where another one can be polarized, and I guess the straight edge is going to be the positive terminal of your capacitor, and the bottom one is the negative terminal. And so all grounds should be, you should have a common ground, so all of them should be connected together when you're creating your schematic. And so in our tutorial later on, we're going to be working with a particular IC, which is basically, it stands for integrated circuits or microchips. And it's essentially a set of electronic circuits on a small flat piece, a small flat like chip of semiconductor material that's like typically made of like silicon. And so you can just think of it as like a black box for a really complicated circuit that's like contained in here. So if you look up like IC on like Google, you just see like different like microcontrollers, like you might find like the 555 timer IC that we'll be using later on. And they're basically, the IC symbols are rectangles with numbered pins. And on the, physically, you'll see that they're numbered from the top left counterclockwise. So it'll go from 1, 2, 3, 4, 5, 6, 7, 8. But on a schematic symbol, that might not be the case. Some people just like kind of design it themselves, and they can just put it wherever, because when you put it on your board, it will be differently numbered. So right here we'll have this is like a schematic symbol that you might see, and instead of going counterclockwise from the top left, it can go from the bottom like clockwise instead. And so, like I mentioned before, we're going to be working with the 555 timer IC. You don't need to know like all of the specific details of like the 555 timer, because It's supposed to be kind of like a plug and chug kind of thing. And this workshop isn't for like to learn about the 555 timer. It's more to learn about like getting comfortable using Eagle and doing PCB design. And so, like I mentioned before, the numbering of the schematic symbol might be different from your actual physical IC numbering. So like this is, I have like just like a little short video of what like the 555 timer might look like. Hope it loads. So it's letting an LED kind of like blink, because as a 555 timer, it can be like an oscillator, like a pulse generator to the LED. Is there any like, are there any questions like so far? I don't want to like go too fast. You can just type in the chat if you have like any questions. Okay, I'm gonna just move on. All right, so here's a process to add new components. Like we mentioned before, you can go on your toolbar and go to that add icon, or you can actually go on your command line and type in add, like ADD, and then press enter, and this window should pop up. And you can use the search function to look for our 555 timer. You have this star symbol before and after the 555 timer, just to denote that there can be any character before and after the word 555. And so we're going to click this LM555N timer right here. You'll see the schematic symbol right here and the footprint right here, which is what will physically be on your board and how it would look like. You can also search for like the part numbers, and need to make sure you're paying attention to the actual footprint. Because if you're looking for like a resistor or like a capacitor, you want like a through hole component, you need to make sure that your footprint is through hole and not like SMD. And so I guess after you click this right here, our LM555N component, you're just going to click OK. And then you can place it on your viewer window so that your component is right there. And then automatically, if you move your mouse around, you'll be able to add more components until you press escape, the escape key. And so the rest of the components we're going to be using is this LED right here. You can see the schematic, the footprint, a resistor. You see the schematic, the through hole footprint, and then a capacitor right here. You don't have to do that right now, but just like for reference. And so once you have like all of your components on your viewer window right here, you want to move parts to where they would be kind of like in their final place, where you have your schematic, because you don't want just like a random resistor kind of just like out there and like have it like too cluttered. You want to make it as organized as possible. You can rotate your parts as necessary. You'll see that later on that it's pretty helpful. And just reposition your components using the move command like right here. And so once you've had all of your components placed, you want to kind of wire up the connections. So all you have to do is click this net icon right here, and then click on a pin and then connect it to one end of a component. And so a green dot means that a node has been made and that it's connected to these two components. So like right here, if you have a dot, this denotes that this discharge pin is connected to R1 and R2. If there was no dot right there, that means there wouldn't be a connection, and it just looks like it's connected, but it's not. And you have to be like very careful for that, because you might get like errors later on. And so the general process of your schematic design is to move your components to the correct place and then connect them using the net command. And so this is what your first draft would look like when you connect your components together. Right now we have a generic power source that we found like when we added a component, it says 9 volts right now. There's like a lot of wires that are kind of like crossing together, even though they're not connected. So you can see see pin 2 right here is like crossing like 4, and like it's not connected, but it's just like it could play tricks with your mind. Um, there's a lot of like unnecessary ground connections right here. So you see the ground right here. You also have ground right here. It goes along everywhere, and that can kind of get a little too messy. So what we will do is use labels. Labels are to basically name your wires. And it's the same concept as using wires. Like you don't have to use it, but it's just like to organize everything better. You typically use it for like ground and power because those are signals that are commonly used throughout like your schematic. And so this is what you can start off with. Like you have a wire between R1 and R2, they're connected. But if you add like a label, if you cut this like wire and add a label to each of the components nets, then they'll still be connected. But it's just kind of like, it looks separated, but it's actually connected. And so here's like the process of how to actually add a label. You draw a little wire stub. You click the label icon right here. You can name the label like ground or power, whatever pin you want it to be, and then it will connect to other labels of the same exact name. And so now we have a schematic that looks a lot cleaner. We have labels on our nets. We see that there's a lot fewer wire crosses. We have a non-generic power source, so we can see that it's labeled battery instead. We have labels for ground, so we can easily identify that. And then the next step, this is a surprise like Amazon gift card giveaway. I just need to get rid of this so you guys like can see this. Okay. So here's a quick pop quiz for the Amazon gift card. Is R1 connected to R3? Or is R1 connected to R2? Or is R1 connected to both R2 and R3? So here's R1, R2, and R3. And you need to explain how can you tell if two wires are connected in your schematic. Okay.
Looks like Desmond might have been the first one to give a reason as well as the answer.
Okay, Desmond, can you send your email to me privately? Okay, but great answer, everyone. You guys basically got it all right. And so let's see. Desmond, congratulations, you got the Amazon gift card. So now I will bring it back to Travis, but before that, do you guys want to do like the hands-on like tutorial right now for the schematic and then learn about like how to do the board design, or do you want to just jump straight into the board design? I'm going to launch a poll right now real quick.
Yeah, we can either go into the hands-on creating of the schematic right now, or we can learn about how to create a PCB, then do the whole thing hands-on afterwards. So,
oh gosh, sorry, there's like a bunch of tabs open right now.
Julian says do PCB first, I think. Anybody disagree, agree?
Okay, I'm putting I'm putting the question right now. Okay, I'm launching a poll right now.
Great. It's very close.
Oh, it's like you guys can see it in progress. Oh wait. Okay. We have 28 people, 29 people. We need one more. Or maybe that's you, Travis. Actually, I think we're done.
Yeah.
So 18 people voted for later and 11 people voted for now. So we're gonna do it later.
So don't panic if you voted for now. I will definitely go over everything again in depth and make sure everybody's got it later on. So Jackie, do you want to take down your screen share and I'll put mine up for now? Fantastic. Okay. Let's pull this up. Great. Can everybody see that?
Yes.
Okay. Fantastic. All right, so what we're going to do to actually switch over, change the pointer, is we're going to click this little schematic to board option right here. I believe that's usually available on the schematic side. Sometimes it isn't, and in that case, you can go to like File and then schematic to board, and it does the same thing. So what this will do is it will generate a board layout based on the schematic that you've created, and you can see what that looks like on the right. We have this black region right here, which represents the actual area that our board will take. And you can see our components all jumbled together off to the side. So we're going to need to arrange those on the board in a minute. But for now, let's just take a look at this window again. It looks pretty darn similar to what we had when we were creating our schematics earlier. Like you can see, we have the move option up here, rotate, group, and those. But then there's also some new options below that we're going to talk about in a little bit. But for now, know that this one's called route. It allows you to route your connections. This is rip up. This one is polygon, and this one is rat's nest. So those are sort of the four big ones that we're going to use a lot in the PCB design. So in case we haven't explained it a lot before, the PCB design portion of this is like the actual arrangement of the parts, how they will look once you create your board in real life. So that's what we're going to proceed to do next. So our first step, of course, is going to be bringing those components that were jumbled on the side here actually onto the board. And so we've got some rules of thumb that we want to think about when we're doing that. And one of those, probably the main one I think about, is try to avoid crossovers of these little yellow wires. These are called air wires, and they represent the green traces that you made in your schematic. So they represent future connections. But bear in mind that as they stand, the connections have not actually been made on your circuit yet. This is just telling you where they will go for later. So what you're going to want to do is try to avoid crossovers as much as possible. Like I have direct lines from capacitor 1 to the chip right here, and direct lines from these components and such. So that's step number one. If you can, you want to also make these air wires nice and straight. Like I like doing straight connections, like from C1 to the chip right here and R2 to the chip. And also a great way to do both of these things is by centralizing your popular components. Like we can see that the 555 timer chip in the middle has 8 pins. So it's going to have a lot of connections. So it can make it a lot simpler for us if we put that in the middle and then put the circuit components surrounding it on the board. Now, here's also where the rat's nest button is going to come in handy. And that was this little one over here to the side. So what that does is it will reroute your air wires. So if I, for instance, were to move this component right here all the way over to this side of the board, then the ground connection right here would actually be closer to this ground connection than to that one. So if I move it over here and then click rat's nest, instead of having an air wire from over here to here, the air wire would actually go from this part to the capacitor over here. Hopefully that makes sense. If it doesn't, feel free to just speak up and ask questions about that. It'll also become a lot more clear as we do the hands-on demo later. All right. So let's also talk about the grid real quick as it pertains to PCB design. So if you want to make sure you're placing your parts with precision or just want to know the dimensions of your board and where you're placing things, you might want to turn on the grid. And how you do this is by going up to near where it says layer on the top, and then you can click this little grid button and a display will pop up like this. And now to actually turn your grid on so you can see it, you'll want to click the on part right here. And you can choose a size to have between each of the lines in your grid. A dimension that you'll notice is used a lot in PCB design is called the mil right here, which you might not be familiar with. The mil simply means it is 1/1000th of an inch. So that might seem a little odd, and it kind of is. But if you would prefer to work in millimeters, which some people do, you can also change your dimensions to millimeters. You see, one other thing that's worth noting is that there is an alternate grid, which you can access by clicking the Option or Alt key, and that gives you a lot more precision when you're moving components, and that's what is set by this 5 down here. So let's get into that a little bit. So you can see what the grid looks like after I've turned it on up here. So one thing you'll notice as you're placing parts is that your parts, if you move them around, they'll sort of click from grid vertices to grid vertices. They won't move smoothly. So if you want to place something not exactly on the vertices, but do it in between them, you're going to need some sort of way to do that. And that's where our option clicking comes in handy. If you're moving around a component and hold down the option key while doing so, you can move on that finer grid that we mentioned earlier, so you can get a lot higher precision when placing parts. All right, now one other good thing to note is that when you're moving around your cursor within Eagle, you'll see these little numbers right here changing. And so the number on the left right here, that indicates the size of your grid. And these numbers indicate where exactly you are on the coordinate plane that your grid makes. For instance, if I was over here on the bottom left of it, where this little yellow cross is, that would be 0, 0. And as I move up the board like this, my X and Y coordinates would change depending on where I am. And this is like a really quick way you can measure the dimensions of your PCB, like if you move your cursor up here. All right, so hopefully all that's clear so far. Now we're going to get into something that's called polygons. So first, how you create a polygon is using that little option we showed over here earlier. What you do is you'll just click on that and then pick something outside the corner of your PCB. Just click there and then drag across to here, click again, and then place all 4 lines until it's connected again. So you've surrounded your PCB. So after you do that, you will just name it. You can right click on it and then click name, or you can use that old name button that we talked about before. And you're going to name it with one of the signals on your board, like we're going to do ground. So why exactly are we doing this, you might ask? And we'll see that right after we hit rat's nest. So you hit rat's nest again, and then this happens. So basically what we've done is created a trace all the way across our board. So now instead of actually having to have wires connected to the ground over here, we have a PCB wide trace that connects to each of the grounds. So we don't have to deal with those air wires anymore. Like you can see that over here, we used to have air wires going from there to there and over here and all the way over there. But when we change here, you can see that we don't have to have those air wires anymore because they're just connected directly to this ground plane. So this is the concept of planes in PCBs. And the free version of Eagle allows you to do this twice, once on the top of the board and once on the bottom of the board. And this will save you a lot of wiring heartache because now we've eliminated like 5 air wires and we don't have to route them anymore. So there's a lot fewer opportunities for unfortunate crossovers. So let's go over a few rules about planes. One of the big places I would recommend using them is like we did in the last slide, which is for ground, because there tend to be a lot of connections to ground, and also for power, if we've got a lot of components that need to connect straight to like the battery power or something like that. Now, you're not going to want to use it if you've got an analog signal, and I don't think we're going to be worrying about that for a little while, especially not in today's demo. But if you do have an analog signal that you want to keep with a lot of integrity, then you're not going to want to use a plane for it. So a couple other little things. Most of the time, or a lot of the time when you use it, a plane will take up the whole layer of your PCB or the whole side, but it doesn't technically need to. So what I could have done in the last slide is I could have made my polygon only surround half of the board, and then only half of it would have that particular trace. But one thing you do want to know is that if you're using a smaller plane like that, you can't cut it off from its source. Like in the last slide, we can see that since this is our little battery connection over here, this is where our ground signal originates from. So we need to make sure that our plane does have a connection to that. So if I were to make a smaller plane over here, and if it's not connected to ground, then I'm in trouble. So just make sure that's connected. Alrighty, so we've done a large trace called a plane, and now we want to get onto our smaller connections. And we do that using the router. So this is actually a very similar process to drawing the connections that we did in the schematic section earlier. All you're going to need to do is click on the router button, then click on one section that you wish to connect, drag over, and then click on the second one. And there you go, you've placed your trace. So there are a couple extra things we need to think about when we're making our routes, because these are actually the traces that are going to show up on your finished PCB. So we have to worry about something about their physical dimensions, and that's their thickness. So if you're doing a digital trace, which is just basically an on or an off, it can be very thin. It can just be something like 6 mils, maybe even a little smaller. And you can see you can adjust the width in the top right corner right here where it says that. If you're doing an analog trace, you're probably going to want it to be bigger, at least 16 mils. And if you're doing something that's power, like for motors or something like that, you're going to want to be very beefy, very thick, so probably 45 mils or above. But a good rule of thumb for all of these is that if you have the space to go bigger, then it really can't hurt to go bigger. And one last thing to note is that if you make a mistake, don't worry, there's the rip up button that we mentioned earlier. If you click on that, you can simply click on traces that you've already made and they will go away. It will leave you with just an air wire. Although if you click on the air wire with rip up, you might destroy that particular connection, which is not good. So be careful about that. All right, is this all seeming good so far? Any questions? All right, I think we're good. Okie dokie, so we can see that I have routed most of the board right here. So I made all these connections. One thing to notice is that after you make these routes, one thing Eagle does is it will actually show the names of the traces. Like this was BAT as we labeled it earlier. And so all our BAT connections will have that BAT name on it. So we can just see right off the bat what the trace is named. And so all the other ones have just automatically generated names given by Eagle. If you'd like to be descriptive, you can, of course, go in and name these traces as well. So one thing you might be noticing, though, is that there are two traces or two air wires that I have not connected. And that's because they cross each other. You can imagine that if we're drawing copper traces on the top of the board, if we draw two traces over each other, they'll connect. And so if we don't want these two to connect, then we're going to have a problem. So one solution that you could probably do is you could take this one and route it all the way around the outside of the board right here, and then go over to here, and then connect this one across the middle. But with a lot of more complicated boards, you wouldn't have that option. So what we can do is something called routing on the bottom. So I mentioned that Eagle gives you access to a 2-layer board, the free version of Eagle. And so that for us is a top and a bottom. So all we have to do here is to go to the layer section and click on the arrow, and we can select bottom. And now we can just go to the router, click on the trace. It'll be blue, indicating that it's on the bottom, and we can route there. And we can route the other one on the top. So now, since these traces are on opposite sides of the board, we don't have to worry about them connecting the wrong way, and we're safe. So one thing to notice about this as well is that the reason this works is because we're dealing with through-hole parts, which means that we can easily connect on the top and the bottom. If we were dealing with SMD parts or surface mount parts, we might not have this option. And in that case, we would use something called vias. So a via is basically a trace that you can draw between layers of your board. And so the process for making one is like this. You're going to start drawing your trace like you usually would. And then you realize, oh, wait, I can't go across this right here because then I'm going to make a connection I don't want to. So what you can do is you can press the space bar and it will, whoops, let me get out. And you can press the space bar and it will start making that via for you. Then you can click. Then you're automatically shifted to the bottom layer. As you can see right here, you continue drawing your trace. Then you can click the space bar again, drop another via, go back up to the top and connect. So hopefully that makes sense. This is something that you want to, once again, if you're dealing with analog traces, you kind of want to be a bit more careful. So you don't want to do too many vias if you're dealing with analog traces, but for digital or power or other things like that, then vias are a great option for you. So hopefully that all makes sense too. Let's continue. All right, so now let's do a couple things to spruce up our board now that we've made all of our connections. So since this black area is the actual size of the PCB that we'll eventually be making, we can actually trim its dimensions just by clicking the move button and then clicking on a side and dragging it inward, just so we're not wasting any space. And we can also make any final positioning changes that we wish to. One other thing about routing is that it's usually good to avoid right angles in the middle of your routes. So if you have any of those when you're cleaning up, you can see if you can just soften them to 45-degree angles like this. All right, so it's time for our final step now that we've actually done most of the hard work. And that is something called the DRC, or Design Rule Check. And I'll show you actually how to get to this when we do the hands-on version. But for now, we'll talk about what it actually means. So what the design rule check does, as you can imagine, is it checks whether or not we've violated any of the rules of PCB design boards. And so what we're going to do is just click on DRC, then we can click OK down in the corner, and it will give us a list of errors. So the list of errors is going to look a lot like this. If we want to see what the actual exact errors are, we just click on the particular error, and it will give us a box around where that error occurs, and we can look at what the problem is. So here it's an overlap error. So we can see that two different signals that should not be connected together are connected together. In this case, that's N3 and VCC. So then we have to figure out how to fix this error. So some common kinds of errors that we might get into are clearance errors. And those are when a trace is too close to another trace or via. And that means that in the manufacturing process, if they get too close, a connection might be made that you really don't want to make. Overlap is what I just explained, and that's what's happening here. Dimension means that you've made a trace or put one of your components too close to the dimension line or to the edge of the board, and that's going to cause problems during manufacturing. And perhaps the most subtle of them is the wire stub error. So a wire stub error just means that somewhere in your routing process, there's just a little bit, like extra bit of route hiding somewhere. And that's really easy to fix, but you just have to find it first, and sometimes it's very small. All right, so now we've gone over the concept of how to do this whole PCB design thing. And we're going to go over a tutorial of that hands-on in a little bit. Some future topics that you might eventually want to explore are more layers, like the versions of Eagle that you pay for can give you access to, I think, up to 10 layers, which sounds really complicated, and I imagine it is. Also things called via stitching, which we won't get into now, surface mounted components, and designing your own components, which is actually a thing you can do on Eagle. But for now, do we want to do our Kahoot real quick before we get into the actual workshop? All right, we'll do a Kahoot for another Amazon gift card.
You got the link, right, Travis?
Yes. Let me see.
Oh my God.
Can you find it, or should I grab it?
Is it on the? Let me see if it's on.
Give us a second, guys. We'll get there in a moment.
Just logging in right now.
In the meantime, any questions based on what we just talked about? If you do, feel free to ask.
Okay, I got it.
All right, great. Let me go
what? Share screen.
All right, Grace, in answer to your question about right angle traces, which is a very good one, there's some debate as to whether or not it's actually a myth, but they say it can sort of disrupt the integrity, especially of an analog signal, that rounding that bend instead of sort of going more smoothly around it. So some people say it's not real. Some other people say it is real. So it's just best to be on the safe side for that.
Sorry, go ahead, Travis.
All right, so it looks like we've got our Kahoot up now.
How can I?
And as mentioned before, this will be for a $5 Amazon gift card. So bring your A game.
Can you guys hear like the music? Is it like too loud? All right, let's see, we have 29 participants, so we should see 27 people. Someone named themselves Tina.
guess we'll wait another 30 seconds for people to sign in. We'll get
Sunny,
started.
okay. Yes, I will. Let me just. Michelle Obama. Did everyone go? Voting elections tomorrow.
All right, we've got 25 people, so we'll start in 10 seconds or so if nobody else is joining up.
Whoa, how did David make his name upside down?
Wow, I like it. All right, we're good to go.
Okay. Everyone prepare your fingers or to click fast. We're gonna start. Gosh. Okay, what does PCB stand for? Prefabricated circuit board, printed circuit base, printed circuit board, or prefabricated circuit base? This is also for a $5 Amazon gift card, so you can buy yourself some candy. I don't know what else you can buy with $5. All right, majority. Let's see the results.
Nice.
June 6787078. Jeffrey T. You guys are in the top 3. Tay and David. Right, so what software are we using to design our PCBs? Autodesk Tinkercad, Autodesk Maya, Etch-a-Sketch, or Autodesk Eagle? Awesome. Everyone got that right. Ooh, leaderboard is changing up. Justin, you're too quick. The free version of Autodesk Eagle allows the user to create PCBs with up to 4 layers. True or false? It's false. It's 2 layers, I believe. Right. In what direction are IC pins numbered physically and not schematically? Clockwise or counterclockwise? It's counterclockwise. Sometimes schematic will have it clockwise instead, and it's just inconsistent, but it is what it is.
It's random sometimes too.
What are polygons typically used for? Analog signals, ground and power, create more air wires, or the aesthetics? Yes, ground and power, since those are the most used in your PCB. Okay. Oh, Taylor or Tay went up the leaderboard, followed by Arnav and Jeffrey.
Very nice.
You can cross wires on the same layer that aren't connected on the schematic. True or false? Julian and Desmond, I like the aesthetics text. So you cannot cross wires on the same layer. You're basically going to short those 2 nets together. You already said in the schematic that they're not connected, but on your board, you connected them. You cannot do that. Ooh, Preston, Jeffrey, and John. It's very close. Right, last 3 questions. What are vias used for? Connecting traces on the same layer, connecting power and ground, making connections through layers, or making instant coffee? Yes, they're making connections through the layers, not on the same layer. And you should also not connect power and ground together ever. You will short that together. Okay, let's see. Jeffrey, June, and Amy. From 1C to 3Cs, how thick should your power traces be? This should be very obvious. I'll be disappointed not everyone gets this. You need 3 C's for your power traces. You want it to be extra, like the thickest of all your other signals. But pretty good, everyone. Majority. All right, Des went up to 3rd place. All right, true or false, LeBron or Kobe? There's actually a right answer to this. This is just a random question, but this could bump you down.
Ooh.
No, the right answer is true.
8 of you are not Lakers fans.
I'm sorry, that puts some people down. All right. Last question. What is the DRC used for? Ensuring no violations are made in the schematic design, making boppin' hip-hop music, designating your routing channels, or ensuring no violations are made in the PCB layout. A little tricky here. Right, it's ensuring no violations are made in the PCB layout. You will have an ERC. We didn't cover it, but that's for your schematic design to make sure everything's electronically connected to each other correctly. Let's see. All right, podium, 3rd place, Amy, congratulations. Des, 2nd place, you came up. And 1st place is Jeffrey. Congrats.
Nice job, Jeffrey.
Jeffrey, wherever you are, can you please send me your email? Okay, I'm gonna take note of this real quick. All right, we're done with our Kahoots. I will stop sharing.
Alrighty, let me share my screen now. Okie dokie. So does everybody have Autodesk Eagle downloaded now? If you don't, just put it in the chat and we'll worry about that. If nobody puts anything in the chat, no, assume that is a yes, and good job, everybody. We can get started in a minute. All right. Let's see. 1 second, let me change. Share. Okay, here we go. All right, this is the correct screen. Okay, can everybody see my Eagle control panel?
Yes.
All right, fantastic. Do we get any chats in the meantime? Cool. Okay, so we're going to go through the process of creating our very own simple schematic and PCB design, and we're going to do something very similar to what was shown in the lecture, which is a 555 timer-based circuit. And so if you want to see the exact circuit that we're doing, it's actually in the last page of the slides with the blue 555 timer chip. So the first thing we're going to want to do is actually create our project. And to do that, you're going to go up to File. I don't know if that actually shows my screen share, but you're going to go up to File, New, and then New Project. So once you've done that, you can name your new project right here. And so you can call it Demo. That's what I'm going to do. You can name it whatever you want to. And so that creates a new project. But as of now, it's empty, which is not good. We want a project that actually has something in it. And what do we want in it? We're going to want a schematic. So now what we're going to do is, while that's highlighted, go back up to New and then click Schematic. There we go. So I'm gonna have to change my share, I think. You share schematic. All right, has anybody not gotten this far? Feel free to speak up out loud because I can't really see the chat if you haven't. And really don't be shy. We'll go as slow as we need to get everybody to get this. All right, so I'm assuming that's correct. So our first step is going to be finding the parts that we're going to need. So you might want to just get accustomed to your viewer window as well, just to see where everything is. So as you may recall, the way to add a new part is over here. So we're going to click on the add part option. I don't think that's showing. All right, one sec. I'm just going to choose desktop. I apologize for if this gets confusing. Okay, so can everybody see this add parts layer now? Or can anybody not see my add part screen now? All right, great. So this might seem kind of confusing. Sorry, what? Good, all right. Actually, first, so you guys might not actually have those parts, all of them right now. So first, let's actually go into the library option right here. So up at the top next to tools and file and everything, it says library. So you're going to click open library manager. And so after that, you're going to click available. You should have a lot more things available than I do right now because I've already imported all of them. So you're going to want to highlight all of them and then you're going to click use right here. So if anybody's having any trouble with that, then please speak up. All right, so just click use. And then, so basically what this is doing is that there's a lot of libraries of different parts that Eagle provides you. But if you actually want them to be available for you to use, you're going to have to go to your library manager first and just make sure they're listed as available for you. All right, looks like we have a chat. Yeah, just go ahead and import everything. It might seem like a lot, and maybe it is a lot, but that's why the search function is so great within our adding parts thing, because I just like to find parts from a bunch of different libraries. So I'm assuming everybody who's, one sec, more chats. Might take a while. All right, I'll just play around a little bit while that's happening then. Okay, so real quick, we mentioned the design rule check, which we'll eventually have to do later on. So just for your reference, if you want to find that, it's in the extended menu, which is down here, and that will pop up next to ERC once we're actually on the schematic side, on the PCB side of all this. So let's see, anything else? So we went over a bunch of basic controls already, but there's also some extra ones that we don't use quite as often, like mirror right here. There's also layers right here, which we won't actually have to get into much today because we're not going that in depth on it, but you might worry about eventually. One thing that I don't think that we went over with labels is that if you want to make a label actually have the tag outline around it, you're going to want to go over here and click this. I think it says XREF on, and that just makes your labels a little bit easier to see. So how's the progress going for downloading those libraries for everybody? Hopefully I didn't just break 480 to go. That's progress. Okay, let's see. Anything else? There's also things like text right here and other shapes you can draw on the schematic, though I don't think I've ever actually had occasion to use those. Okay, more chats. 440, all right, still going. So has anybody already, I guess nobody's probably already got all of these downloaded. Almost there. Great. So I guess actually while that's going on, I can just go through some principles of adding parts just to make things easier when we eventually do get to it. So once you have all these libraries added, it's going to seem like a lot of parts, and it is a lot of parts, but one of the way we're going to get through all of these in a lot simpler fashion is by using our lovely search option down here. And so the best way to actually search for parts is by using the double asterisk notation. And so that just means putting an asterisk on either side of whatever part you're looking for. And what this does is an asterisk stands for any key. So you won't be limited by having spaces on either side or nothing on either side, because it can be anything. So if I type resistor and then type enter, then we'll filter out everything that does not have resistor somewhere in its name. And so if we find some resistors right here, you can see as soon as I click on it, on the top right, we get the symbol on the schematic, which is right here, and that just looks like any old resistor. And then to the right of that, we get what it'll actually look like on the board. And so today we're just doing through-hole parts. So this is what a surface mount part looks like. So if you see this when you're looking for resistors, this is not what I'm looking for this particular design. And that's what a lot of these look like right here, but they're all varying sizes. There's actually a little description of it right here, the package size, and so on, and actually the dimensions of the part. And so on. And you can see there's a whole bunch of different libraries in here. Like these are from the SparkFun library, SparkFun resistors. So let's see. There should be some non-surface mount ones somewhere, and that's what we're actually going to end up looking for our design. All right, so it looks like these are all surface mount. So you can just keep on scrolling through. You can see that, for instance, the European resistor symbol is just the simple box with leads coming out of it. Whereas, let me just shrink that up a little bit. Whereas the US shaped resistors have the little squiggle right here, which is our usual resistor shape that we think about. And so you can just keep on scrolling through until you see something that looks like about what we want. This looks like about like the resistors that we're used to. So that'll probably be what we end up selecting when we're looking for resistors. So let's see, how is our progress going? Eric's question about question marks. I honestly haven't put question marks around the word. One sec. Let's download the ones we use. All right, great. So do you guys have that option? All you guys have the option to stop downloading? If you do that, actually might be a good idea. And you can just download whatever particular libraries I use. It's been a while since I've actually done this. I didn't remember exactly how long it took. So if you guys can do that, then go ahead and stop it. And as I use libraries, then you can see if you've downloaded those yet. And if you haven't, you can go and find them. So in that case, I will just get started with finding our first part, which is going to be our 555 timer. So what do you think I'm going to put in the chat? What do you think I'm going to put in between our little asterisks? Anybody have any ideas if I'm searching for our 555 timer, what I'm going to put between them? Right, exactly, Justin. Yes, we're going to put 3 5s and see what happens. All right, so you can see there are some parts that probably aren't going to be what we're looking for, like this 4555 timer right here, 4555 chip right here. But then we get to some that might look a little more like it. So this might be tempting for you to get. It looks like it's got 8 outputs, but this part looks like it's going to be surface mounted, not through hole. And for our design, we're looking for through hole pieces. So I think I'm going to go over to the SparkFun ICs. Let's see, does that look right? This one actually looks pretty good. So sure, why not? Let's go with the SparkFun IC Special Edition 555 kit part right here. So if you guys don't have that library, this is you might want to go and look for it real quick, the SparkFun IC Special Edition library. Download that and then find this 555 timer. Check the chat, make sure that's going okay for everybody. Yes, through-hole components, which you'll see in our through-hole soldering workshop or later this quarter. That literally means that there is a hole through your PCB that you stick your parts into and then solder it to. Surface mount, on the other hand, which we'll actually be having another soldering workshop for next quarter, means that the part is just on top of the board, on top of the pad. It doesn't go through and you have to solder it directly onto the board. Great. So I'm going to select this 555 timer piece by clicking OK right here. And then I'm just going to place it. Do note that this little cross right here is sort of around the indicator around which all your parts are settled. So everything should be sort of above and to the right of that little cross. So I'm just going to stick this right here for now. And so you can note, as we talked about, that this is not ordered from the top down and around counterclockwise. It's not 1, 2, 3, 4, 5, 6, 7, 8 like that. Instead, it seems like sort of it's random to us, although I'm sure the person who did it had a reason why they did it this way. And you can also see that if you wanted to, you could place more than one of these, although we're not going to need that for our particular design. So if you want to add another part immediately, you can click Escape and that will take you back to the part selector window. In this case, I didn't do that, but we'll get back to adding parts in a minute. Let me just check that has anybody not managed to get this 555 timer successfully? Let's see the chat. Yes, SparkFun Special is where I got this one from. I can go back to that in the library right here. SparkFun IC Special Edition. So hopefully that library won't take too long to download since it's just a single one. I'll wait like another. Is there a specific drop down you use? Could you clarify drop down, Eric? There's a 555 and a 556 drop down from here, if that's what you're wondering. Yeah, and 555 kit is the particular one that we're using. Because if you see the 555D, it looks like a surface mount component. 555P, I mean, that looks like just a slightly bigger one. So 555 kit should work. All right, fantastic. So I'm going to assume that everybody's got this far, and if not, we can slow down a little bit later. But next, I'm just going to start looking for some resistors because we've got 3 resistors in our design that we need to make. So I'm going to type resistor. I'll just make it lowercase, not entirely sure it's case sensitive, but then we're going to enter search again. And so I've got a whole lot more libraries than you guys probably do at this point, but I'm going to look through my libraries and see our US American symbol. That looks good. One of the things that indicates that you're probably just going to get a general surface mount, a general through hole resistor is when it just says RUS right here. And so I'm going to find 20710. This looks about right. Or 2077. So either of these two should be fine. This looks like it's from the BeagleBone Black Wireless library, if you guys want to find that real quick. Or if you already have a library in there that has some sort of resistor US that's showing footprints like this, you can also go with that. So I'm going to click OK, and I'll start placing resistors. We know in our final design, based on the circuit that we're using, we're going to need 3 of these. So I'll just place 1, 2, 3, and I can move them around later as I wish to. And you can see that Eagle has automatically named them R1, R2, and R3 for us. So let me go back to the part screen. So hopefully everybody's getting along all right with this. Let me know if you're having any troubles with it. Let me check the chat. So Eric, if there are multiple under 555, try to pick one that had a similar footprint to the one we're using. Since you don't actually have a part like already ordered that you're basing it off of, so you just have to do something similar to what we are for the moment. It doesn't matter if you choose one that's slightly bigger or not. Alrighty, so if anybody has not gotten resistors yet, feel free to type it in the chat and let me know. Otherwise, I'm going to move on to the capacitors. And so to define those, we're just going to use the same sort of theme we used before. Just put capacitor in, and now we'll look for those. Hey, it looks like in our BeagleBone Black Wireless library, we might have some capacitors US symbol as well. So let's take a look in there. So this one looks promising. It's got a relatively small footprint, like what we're looking for. So I'm going to click that. This should be good for our non-electrolytic capacitor. So hopefully you guys are finding this easily. We're just going to click that and add it. Now it's worth noting that there are capacitors which have polarity, like this one, capacitor 1 in our schematic. And those, you can see it has a plus sign next to it indicating the side which is positive. And there are ones that are non-polar, like this one that's connected to pin 5 over here, and that's just got 2 straight lines. So technically it doesn't really matter which one it doesn't really matter at this point which one we're using if our footprint is correct. But let's find an electrolytic one next. So let me check the chat real quick again.
Capacitor again? Can you show the price?
Sure, certainly. All right, find that. All right, so yeah, we're just in BeagleBone Black Wireless, capacitor US. You'll notice that as you move up and down The footprint changes, although the schematic symbol really doesn't. So depending on what capacitor you're actually planning on ordering, you're going to want to change which one you select. But I believe I just selected the second one up right here. It's not the very smallest of them, but the second smallest. All right, so let's keep on moving down. And you can see as we go further down, we're also getting options for surface mount capacitors as well. And for our purposes, I'm just going to, yeah, one sec. Let's look over here. For our purposes, I'm just going to use 2 of the same capacitor, so we don't have to go through the rigmarole of selecting more parts. Dominic, in answer to your question, we can add a specific value later. You don't have to worry about the values that you add. Like even if you selected one that particularly said 0.1 microfarads or whatever, you can always change that later. So just select one that looks like it's got a footprint that you're looking for. Okay, so I'm just going to pick 2 capacitors with the same footprint right now, although technically our electrolytic one might have a slightly different footprint than our regular nonpolar one. So I'm just going to use our copy function actually right here, which is another one we might not have talked about so much. Just click on this component, and then you can see we've made a second one. And we can just move this down a little bit, and it names it capacitor number 2. So there we go. We've gotten most of our parts already. Let's see, what else do we need? So we're going to need an LED. As you can see, L1 right here will be the LED that blinks in our completed circuit. So let's take a look for that in the parts section. And as usual, we're going to make use of our lovely search function and just type in LED. All right, I think BeagleBone has been our friend today. Let's see. That looks promising. Maybe, yeah, okay, these look pretty good. So what we usually tend to use are either 3mm or 5mm LEDs. And 3mm, of course, means it's going to be slightly smaller. 5mm is slightly larger. So we're going to select a 5mm LED for now. And the library that we're using right here is a BeagleBone library again. This is just BeagleBone Blue R3 as our library. So search for that in your library manager. And let me just place that. I'll go back to that parts page in a second. All right, so if anybody is having issues with this, then feel free to type it in chat. And then after this, one of the last things we're going to need is just a power source for us to deal with, because our circuit isn't going to be any good if it doesn't have some sort of power. And so to do that, I believe our circuit is powered by 9 volts. So to see the options that we have, I'm just going to click 9 volts in here and see what we have, because this could, of course, either be a battery or some sort of barrel jack or so on. Let me check in the chat. Yeah, program still more character super early. So for most of these, there should be a way you can expand the windows and such. I don't know if I assume that's also in the library manager. Hopefully it is. Yeah, hover over the line and you should be able to expand and change how much is shown for each one. All right, great. So as I was saying, for power, we have several different options. We could have it plugged directly into the wall. We could have it plugged into like a regular 9-volt battery, perhaps a couple of batteries through a connector. I think what I'm going to use is probably a barrel jack if I can find a good one. So let's see, it's probably in power jack, which is in the SparkFun connectors. All right, so you can see this will be just like a barrel connector. So I'm going to select one of these, and that'll be used to power our board. So I think I like the looks of this one. So this is within SparkFun connectors for those of you who need to download that library. All right, SparkFun connectors, power jack. Once again, if you'd prefer to use a different one, hopefully not a surface mount one, but either of these 3, then go ahead. But I'm just going to use the first one. So I'll put that up here to worry about later. So now we actually have all of the components that we need to start making our schematic. Let me drag this out. Okay, chat. Great. So if anybody has not managed to grab all the parts yet, please let me know in the chat. All right, cool, 9-volt one, let me grab that. All right, yes, this is in SparkFun connectors. This is just a power jack. We're assuming that the barrel plug we're gonna plug into it is coming from 9 volts, but we don't have to worry about that. Let me see, LED, which LED are we using? Let's see if I can find that. Okay, BeagleBone blue LED, looks like, from the BeagleBone blue R3, and it's a 5mm. So that's another thing, if you guys didn't see that, one thing you can do if you forget what part you are using is you can just right click on it, and on the bottom of all these options is properties. And then you can see a whole bunch about it, like what library, the device, the footprint, and everything. All right, so I'm just going to start.
Which LED one we're using again, and can you show the 9-volt one?
9-volt one, sure, yes, 9-volt one. It's just up
LED.
here. It's some SparkFun connectors. Yeah, just up in the power jack section. I just picked the first power jack it came across. And so for those of you in Micromouse and Ops, one of the things you're actually going to be doing, if this year is like all the others, is selecting all your own parts. So once you do that, it becomes a lot more important which footprints you select and which exact parts you do. And there are certain websites where you can look up exact parts and then download a library or download a specific outline for it that'll give you both of these, so you can make sure you're using exactly what you need. All right, cancel that. That's great. So we've got all of our parts selected. I'm just going to move these a little bit closer so I can zoom in so you guys can see exactly what's going on. Actually, this is a great time to use the group function. So group, all you have to do is drag around a certain number of components. Then you can go to, for instance, your move and then right click in the general area of them. You can click move group and then they will all move in unison. All right, so let's see, I'll zoom in a little bit right here. And I'm also going to squeeze this in so I can see what I'm dealing with over here. All right, so now we're going to start making our connections. So first of all, it looks like pin 3 is connected. Let me check the chat real quick. Great. Okay, it looks like pin 3 is connected through a resistor to our LED over here. And just to be consistent, I'm going to go with the names of the resistors that they used in this particular schematic. So I'm going to move resistor 3 over to here. Actually, I'm going to connect it. And you see, after it's made a connection, if I drag it around, it automatically makes that little green net for me. So I know it's connected. Great. So I'll have that right there. And then that, as we can see, is connected to our diode. And I'm not going to connect it exactly as seen in the schematic. I'm actually going to rotate it around a little bit and have it pointing this direction. And now what I want to do to connect those parts manually is I'll just go over to my net icon right here, then hover over one of the connections, then just drag it across and click on the other green circle right there. And we've made our connection. So hopefully that's going smoothly for everybody. So next what I'm going to do is talk about capacitor number 2 right here. Actually, I'm still on net. So if you guys are still on net or something and you don't want to be, and you're just finding it difficult to go over here and find another icon without dragging it all over the place, you can just click escape and it will automatically stop that for you. All right, so we're going to go back to move. Let me check the chat real quick. Great. Okay, so we're going to go back to move and select this capacitor. And then we're going to move it about right here. We know it's connected to pin number 5. So we're going to set it down right there. And what I'm going to do is net from here. If you want to start curling around like this, then what you can do just to sort of lock it in this position is click already. And then you can click and then you'll be able to just drag like from here to here. And you've got your connection completed. All right, so next what I'm going to do is let's consider R1. Okay, so R1's over here. I'm going to rotate that just because it looks like it has to be connected over to 7 and 2. Great, and I'll move it a little bit closer over here to where 7 and 2 are. And I'm going to do the same thing with resistor number 2 over here. Move it over there and then rotate. So I don't know if you guys have encountered this yet. I know it's something that I have to deal with all the time, is that you're clicking on a part and for some reason it doesn't seem to be selecting. So one thing you'll notice is that although it might be really tiny, on each part, there's like this little red cross part. And if you hit that, then every time it will allow you to move. If you don't hit that red cross, then sometimes the part just won't select. Other times it will. It's a little bit iffy. But if you're ever having trouble, make sure you find where that red cross is in the parts. All right, how do you get rid of a connection? So that would be just with the delete should work. So you can just go to the delete icon over here and click on whatever trace you wish to get rid of. Alrighty, did I miss any questions? Awesome, looks good. Okay, so now we're going to have to start doing some more connections. So I'm actually going to move this up a little bit. Sure, that should be good. So I'm going to want to connect resistor 7 to resistor 1 and resistor 2. That's not 7. Okay, resistor 1 will have to be connected to 7 and 2. Net here. And right there. So I've connected both of those. As Jackie mentioned before, you can see that this little green dot has appeared, which means that all of those are connected together. And if I want to move things around, you can also move traces like this. You might think that you wouldn't be able to, but it'll actually, the Eagle actually is a very elastic program, so it will allow you to do things like that if you don't like where you initially placed something. And so now we're going to also have a great example of when a connection has not actually been made, because we want to connect pins 6 and 2. So we're just going to draw a cross like this over to number 2. And so even though we're crossing 7, there is actually no connection there because a green dot has not popped up. All right, and we also have to connect pin 2 right here to the side of resistor 2, like this. And then we also want to have it connected to our good old capacitor 1 over here. So we're going to move that over here, connect it, and voila. Okay, so it looks like we've got most of our connections made, although we will also want to have 4 and 8 connected over here. Sure, that'll work. Okay, so you may be noticing one thing now. I've made all the connections of our components, but I haven't made any power or ground connections so far. And that's just because it would be quite inconvenient if I just had to connect all these grounds together. There'd be a lot of extra wires. Instead, I'm going to use the magic of labels. So you might remember that labels over here. So we're just going to click that label option. If you haven't yet, make sure you go up here to where it says XREF on and XREF off. We're just going to click on that. And that means that once you make a label, that it will give that outline for you. All right, let me check the chat real quick. Yes, exactly. Labels are very aesthetic, very pretty. Okay, so we've made our label right here, but now it just says $6, which would be a good password, but doesn't really tell us anything about what it's supposed to be. And so we know that we want to connect to VCC or battery. In our case, I guess we can call it VCC just because they do. So to give this a name, we can do one of two things. We can either go over here to our naming option, or we can right click on the little cross at the beginning of our label. And then you can see we have a whole bunch of different options, and we're just going to click name right here. And so I'm going to name it VCC. Great. So now that's VCC. Both of these are connected to VCC. But then the question is, what exactly is VCC connected to? And our answer for that should be somewhere on the power jack. So you guys won't be expected to know this, of course, but for this particular power jack, this top bit right here is the positive or the VCC, and these two are just simply grounds. So we can connect them like that. And then what we're going to want to do is label those. Let me just check the chat real quick. Sure, yeah, of course I can go over naming. So yes, and as Jackie mentioned, we have our lovely command line over here. So I can just start typing in label, enter, and then automatically puts me on label mode. And so all I have to do is click on the end of a trace like this, and then bam, we've made our label. So if I want to name it, I can either right click on it, or I could even type in name into the command line. And then all I have to do is click on it, and it gives me an option to name. And so I want to connect this in VCC. So I'm just going to go VCC. Then it asks me if I want to connect the two of them, and I say yes. And now it's exactly as if we had a green wire going from over here to over here, except it's a lot prettier to look at. All right, so let me check the chat again. Perfect. All right, and labels should be on your toolbar somewhere. So, but yeah, if it's not the command line, it'll work perfectly for that. Okay, so now we're going to do the rest of our labels. So we think we've got one more that connects to VCC. So let's try doing that now. Oh wait, what's happening? It's not letting me connect anything. So one thing that's a little bit finicky about labels is that you only can connect them to wires or to our traces. So you can't connect them directly on the end of components. So how I'd solve this is just by making a tiny little wire right here. And then I can click the end of it to make a label. And now we're going to name that again. I'll just right click it this time, click on name and VCC. Voila. So the three of those are now connected. But now it's time where I have to connect all of my grounds. And so we're going to do that by creating another label right here, which we're going to name ground. Let's find that, ground, GND. And these are some names you guys should know. A really common representation for our ground is just that uppercase GND like this. So on most of your circuits where you have a connected ground, which will be all of them, you are probably going to want to use that as your signal, as your symbol for it. One other thing to note is that VCC will always mean a power source. So some people will say VCC, especially if it's not a battery you're using, but it's perfectly okay to say power like PWR or BAT, BAT. It all means a very similar thing. So now let's add a few more labels. We're gonna add one right here, but once again, we need our wire stub. Great, and we'll do the same thing right there and right here. And now we'll just add our labels in. Give it ground. Yes. Okay. 1 sec. We'll place a label and name it ground. Yes. And then one last time, we're going to click on this and name it ground. Alrighty, let me see something in the chat. Yes. Yeah, it's that. Sorry.
Can you try to type in label and see if oh yeah, those two
Yeah,
things.
it's xref on and xref off right
Yeah,
here.
that one's just the text, and then the other one is with the little pentagon thing.
I don't really even know why they give that as an option because I can't picture wanting to have it without the little tag. But hey, it's options. So now we have our completed schematic, everybody. We've made all the connections that we've needed to. And so we're ready to go on to the next part of it. So if anybody's having any issues so far, feel free to ask questions out loud or type it in the chat, and we'll answer those before we actually go on to the PCB part. Chat.
Does pin 1 have to be connected to ground as well?
Yes, that's right. Thanks for catching that. I missed that. So I could connect it to a label, but honestly, we're so close to a ground right here. I'm just going to do that.
Oh, someone said, wait a sec, I'm still labeling.
Sounds good. Yeah. And yeah, so we're gonna wait a minute. Yeah, if you have any questions about anything, then feel free to ask.
Yeah, you guys are halfway there. How do you change label names? Yeah,
you can right click on it if you'd like. So if you right click, it gives you this lovely list of options right here, and then you can click name and change it around. Or you could just click on the name option over here and then click on it. Or you could do what Jackie loves to do and use our lovely command line and click name and then click on it. And then it gives you the option. Oh yeah, and that's a cool thing that pops up too. So you see how we have a bunch of grounds now. So if we wanted to change the name, we could do this option right here and say change every segment on this sheet. And then that would change all of the grounds names. So that would keep them all connected. Yeah, but give it a different name. All right, if anybody is not this close or is not caught up yet, then put it in the chat. Don't be shy. We're not trying to rush you, just trying to make sure we're not dillying and dallying when everybody's already done. Yes, that's perfectly fine. Yeah, you can wait. So hopefully all this has been relatively simple for you guys. I know if you haven't gone over any circuit stuff, it might seem a little bit intimidating, but for our purposes, you really don't need to yet know what all this does. You'll be learning all that if you're in ops in the coming months. And so by the time you do know all that circuit stuff, you'll be able to make your own PCBs no problem, which will be awesome. All right, I think I'll wait another minute and then we will get started on the very interesting and new PCB side of all of this. Alrighty, I think I will begin on that. So to generate a PCB from your schematic, what you're going to want to do is go up to the File option right next to Eagle. And then below Print, you should see an option that says Switch to Board. And so that's where you're going to click. And it's going to say at this point that the board for this file does not exist and ask you if you want to create it from the schematic. And you're going to click Yes. Then after thinking for a moment, something like this should pop up.
Oh, I just wanted to add something. Like, you want to make sure your schematic is like finalized before you move on to the board. Because once you make your board and you try to change something on your schematic, your board is gonna have like errors and it's just not going to be fun.
Yes. Yeah, I had that problem with Micromouse last year when I was doing it. At a very late stage in my PCB, we changed something and that made it not compatible with the schematic anymore. And we couldn't find out what it was. So we had to go back to a much earlier version and do a whole bunch of rerouting. So you won't want to change anything. And yeah, for you Micromousers and Aircopter people, that's something to watch out for. Alrighty, so I'm going to assume that everybody's got to this step so far. If you haven't, once again, feel free to share it in the chat and we will help you out. But if you have, you'll remember that our first step is going to be dragging components onto the board area. So we're going to do that in the same way we'd move components in the last section of this, which is just by using our move option right here. So just click and drag. In this particular side of Eagle, the little cross in the bottom left-hand corner is super duper important because that's where your board will begin. So you want everything to sort of be have its dimensions centered around that. Well, not centered, but with that in the bottom left corner. So we're going to move this. As I mentioned, it's probably going to be pretty central. So we're going to have the other components around it. So as I drag the air wires, I'll see where they're connected. I can see that resistor 2 is connected pretty straight onto this output right here, or to this pin on the IC right there. I'll drag this one over here. Then perhaps I'll drag this over here. Then yeah, my goal right here is just sort of to try to make my air wires as straight as possible and as few crosses as possible. And you'll sort of see that visually as you move it around. And that looks like a good candidate for rotation. I'll move this in here a bit. And then this guy over here for now. And this is not by any means near our final placement, but we're just getting everything on the board so we can rat's nest and figure out what our situation actually looks like. And so rat's nest is a very important tool at this point, and that basically means we're going to redraw our air wires and connections to make them as short and convenient as possible. And that's the little option that we have right here that looks like the 5 little dots connected by lines. So I'm going to click on that. And you should see that a few of our traces, a few of our air wires have routed themselves slightly differently. So if I just click Command Z, I undid. Now if I click rat's nest again, they change around. All right, so another thing I'm going to do is just go around rotating a couple components, like this one right here. Beforehand, it had its air wires crossed. Now it doesn't anymore. Let's see, this one looks pretty good too. Now I'll move this around like this. Yeah, once again, the goal is just to start shortening these wires. So before I go further, I'm going to want to start thinking about making planes. And before I do that, I want to trim down our board to slightly more manageable dimensions. And so how you change the dimensions of your board is simply by clicking on the yellow edges of the board and dragging. So you're going to want to make sure these do not get at all diagonal, and it's very easy to do that. So just make sure that you're keeping your lines very straight as you drag it down. So I'm going to drag down to about here for now. And I'm going to go over to the other side and do the same thing. I'm going to drag it in. You'll notice if I try to drag it over one of the traces like this, we'll get a little red part over the area that's over the edge of the dimension board, meaning that we can't do that. It will throw an error. So then we're going to want to make sure it's outside of that. All right. let's see, let me zoom in correctly a little bit here. Okay. Awesome. So this is our board now. We're going to want to start thinking about our polygon because I imagine we have a lot of ground traces right here that we don't need to actually have air wires connecting to. 1 second, we've got a chat. Oh, sure. The dimension part again. Oh, yeah, I can go, or the dimension part or something else. If it's dimensions, then it's simply you click with the move icon onto the side and then drag back and forth, preferably in the middle so it doesn't go diagonal like that. But let's see. Yeah, just like that. And this will probably not be the final dimensions of our board. I've just done something pretty preliminary for that. We can always adjust near the end, but we want a space that is big enough to hold all of our components that we're going to make our polygon over. All right, fantastic. So let's start with our polygon. I'm going to click on this polygon option right here. Actually, let me check the chat one more time. Yes, okay, I'm gonna click on this polygon option right here. So when I'm gonna want to draw my polygon or how I'm gonna want to draw it is outside the bounds of our board. So I'm gonna start up here. You can see that it starts drawing a red line, which will be our polygon. And I'm going to want to make a straight lined box all the way around like this, and then keep on clicking when you want to make a corner all the way around again, and then going to draw up. And then right after I do that, it's going to ask me for a signal name. And since we saw that so many things were connected to ground, I'm just going to make it a ground signal. So like this, it's going to have the exact same name as all those in the middle did before. So great. But we can see that we've made our polygon, but nothing much has happened. And that's because we haven't rat's nest yet. So let's do a rat's nest real quick and see what happens. Alrighty, so it's kind of hard to see now, but a lot of our wires that we had before have disappeared. So it'll be a lot easier for us to actually go back and move our components to make them as simple as possible. So you might be asking at this point, that's fantastic, but how do we get rid of this horrible, ugly red layer that's over the top of our PCB right now? And unfortunately, there's really no good option for that. So what we actually kind of have to do, the only way that we found to make this go away is just click save on your board. You can save it as whatever you want to, let's call it, make sure it has the .brd extension, but call it, I'll call it demo proj, like this, and then I'll save it. So now we can see that our schematic and board have the same name, they're linked together. So I can freely just click the X in the corner of my screen, and then we get back to our schematic like this. And now all we have to do is once again, switch to our board, and then we get the board back up, but without the ugly red layer. And I probably went over that kind of fast. So if anybody has any questions, just put that in the chat. And you can see right now that our connections are still air wired properly. We've gotten rid of those unnecessary ground air wires, but now we just don't have to deal with the big red layer on top. All right, so I'm not seeing any questions about that, so we can move on. So what I'm going to want to do next is now that there's a question. Certainly, yes. So how you're going to want to do that is first you're going to want to save so that all the progress you've made on your board isn't lost. So you're just going to go up to File, Save. It's going to ask you what you want to save it as. So you're going to change the wording before the .brd. I, in my case, named it to demo proj. You can name it whatever you want to. Just make sure you don't interfere with the .brd at the end of what you're naming it. Then click Save. And so what that'll do is it'll name your schematic and your board the same name. Before mine were untitled. And then you can just click X and close down your PCB. And then once again, when you're on your schematic, just go up to File and then say switch to board.
There's another way you can type this in. It's called ripup at. I'm gonna send it in the group or the chat. This is to get rid of like the rat's nest. If you wanted to try
Very
that.
nice.
If you wanted to, yeah. Type in like rat's nest.
That would be more convenient, yes. All right, fantastic. So I'm going to assume that everybody's got that far. If you haven't, please just stop me. And then we're going to work on the final arrangement of our board. Okay, so I'm going to start moving components in. I think we can see that we don't need to have everything as widely spaced as it is right now. So I might even rotate this one just to see what happens. And so there are general rules of thumb for routing boards and for placing components, but there's nothing too solid. Like if I were to encounter this board today as opposed to tomorrow or yesterday, I'd do it differently all 3 times. So there's no particular one right way to do it. There's just some general rules you follow to make it convenient for yourself. Oh, also, one thing you might notice right here is that no matter which way I put it, there's always a diagonal lines going from my resistors and my capacitor to this IC in the middle. So we can use the option clicking thing that I talked about earlier. And so hold down option while you're moving it around, and you can see that you can move it a lot more smoothly than you could before. So I'm going to make it exactly straight and then just place it. And once again, that's not entirely necessary, but it is a matter of preference on my part. Alrighty, so we're getting closer. I think this particular resistor should be flipped. Yes, exactly. Way to shorten the resistors. The resistors, this is the actual dimension of the piece. So I could have chosen a smaller resistor. I believe that was an option. I think I chose a medium-sized resistor. And the benefit of that is that a smaller resistor can fit in a medium-sized hole, but a large resistor can't fit in a smaller-sized resistor hole. So this one's just sort of a little easier to use for more different types of resistors. All right, I'm going to move this power jack in a little bit like this. All right, and now that I've moved my parts in a little bit, one thing I can do is actually drag my dimension lines in again, just to make the PCB a bit smaller. And I'll do that same thing on this side. And after doing that, I can do the same thing actually with the polygon. And that's, once again, it doesn't actually affect how the circuit works, but it just makes it a little bit neater for us. All right, so hopefully everything's going smoothly for you all so far. So we've made a lot of progress so far. We've actually got all of our components laid out in the way they finally will be when we get the board manufactured, if we get the board manufactured. And so now all that's left to do is start routing. So the router, as we mentioned before, is over here on the toolbar. It's this little button right here, or of course, as Jackie mentions, you can type it in here, route, like that. And then all you have to do is click and drag from one to the other. However, you might be noticing that this seems like a little bit of a small width, so we can change that. I'm going to click escape real quick. Now, whoops, let me shorten that. Okay, we're going to click escape real quick, and then there should be a width option right in the middle of the screen right here, which there is. So the width is only 6 right now, which I mentioned can be okay if you're using digital signals, which we technically are. But I also mentioned that if you have the space to do bigger traces, you might as well. So we're going to go all the way up to 16 for now, and we can see how that looks. So then with the routing option, I'll just route across like this and click. And there we go, we made our first trace. So if you want to change the width afterwards, you can do that, I believe, with properties. If you right click on the trace, yeah, the width right here can be changed. So I think we'll go up to 20 for it. Just click OK, and it widens a little bit. And I think 20 looks about good for this board. It won't make it too crowded, so we can stick with that. How did you get rid of ground wires? Yes, that was the polygon that we made earlier. So let me go over the polygon process again. All that you're going to want to do is click on the polygon icon over here, and you're going to start drawing. It's still on router, I think. It's still on router. But yeah, you're going to want to click polygon and then go around it. You're going to want to give it a name. It'll ask for a name. In our case, we gave it GND for ground. And then you're just going to click rat's nest right here. And that will make all the connections, get rid of those air wires for you. Let me see. Yes, and width can be a bit confusing. It sometimes disappears in my mind too. It's just in the middle right here. You've got some options for what your routing style is going to look like. And you've got like wire bend options right here too. You can actually make it curve if you want to. You can make it right angles, and that's just basically what will happen as you move around. Let me demonstrate that. Like right now, if I sort of move around, I have a gentle bend like this, and if you change that up at the top, you can sort of change how that goes. But I like the way it is. Okay, how do you get rid of the big red thing again? I think Jackie's method should be in the chat right now, so you can try that out. A little bit up.
And space at, and then semicolon.
Hopefully that works. If it doesn't, you can use the much less efficient Travis method of just saving your board and closing it out, then switching back to it from your schematic.
Has it worked with other people? Jeffrey specifically? Because he typed it in. Okay, that's good.
Yay. All right, so then I'm just going to continue routing this board a bit. So all I have to do is just go over all those yellow wires and start making connections. And you'll notice that it bends very nicely and easily right here without me really having to do anything about it. Other times it's just completely straight, which is also nice. Connecting. All right, I think this LED might need to be turned around. Let me see. Yeah, great, because we had an air wire going across both of them, and that's just a little bit inconvenient. Let me check the chat real quick. Edit schematic after getting rid of ground wires. Well, the thing is, it actually doesn't get rid of the ground wires. We still got all those connections made. The connections just sort of made under the hood for us because we've got the entire ground plane. So each of these, it's all still connected to ground. So yeah, the schematic hasn't changed. All the same connections are being made. We just don't have to actually manually route it ourselves because there's a trace doing that job for us. All right, so now we're going to, 1 second. Edit schematic after get rid of. You should still be able to move all your components around. I'm just using the move option. I just wouldn't add any new components. So give that another try. Try clicking on move and then finding where the plus sign or the cross is and then moving around. If the connection is wrong. If you make a wrong connection, then you will get an error when you try to like close your board or open it again. It'll say backwards, forwards, annotation severed, which is not good. It's difficult to deal with. So it'll let you know. And also when you do like your design rule check and your error rules check, then you will get an error listed there. Plus sign disappears. The plus signs can be very small, but they should still be there unless you messed with the layers. So see, it should still be in the middle of your parts. Did you click anything having to do with layers over here? Nope.
Take it to, like the breakout room and then try to figure out with him.
All right, sounds good.
I'm gonna assign J.
And so in answer to your question, you actually don't have to follow the air wires to route. It is super recommended that you do so, because if you don't follow the air wires, that means you're making connections that you shouldn't be, which means your circuit will not work out correctly, which means that you might fry components and nothing's going to end up working out for you. So you're definitely going to want to follow those air wires. They're a great guide for you. That's one of the things that makes Eagle so wonderful to use. So we're just going to keep on routing until all of our traces are done. All right, and so here actually you might notice that we're coming across that situation that I talked about a little bit in the PCB section of the workshop earlier, where we've got two crossed wires. So I'm going to make the first connection right here, but then if I try to make the second one across it, it's not going to let me. You can see if you try to drag it over, something like that's going to happen. And so let's go over the fix that we talked about that. And where's wrong my connection earlier? Yes, if you have a wrong air wire, then your connection in the schematic, yeah, it is wrong. So yeah, I would recommend making sure that everything that's in the schematic is consistent with the little blue schematic that is at the end of the slides. Yes, anyway, so routing on the bottom. So we can't route this on the top. We can't cross wires, because if we tried to do that, we'd have two traces that carry different signals running over each other. So what we're going to want to do is change layers. And we can just do that by going over here where it says layers and then clicking on bottom. And there's lots of other layers there too, but bottom is the one we're going to deal with for now. And so we can just go through the same process. So Eagle automatically knows to make this trace blue now, just to indicate that we're on the bottom of the board. And so we can just draw across. And voila, there we go. So we've made this connection. Now, actually, let me go over real quick. So I'll go over rip up real quick actually, and then get into the next thing. So rip up is what you can do is you want to get rid of a route you just made. So all you have to do is click directly on it and it will disappear like this. You can do that in sections. Now, do not click rip up. If you like double click it, I think there's a way you can get rid of your air wires. So just be a little bit careful not to click rip up too many times on those. All right, anyway, let's go back to the top real quick. So I mentioned using vias was another way to sort of get under traces, and this is how you do that. So you're going to start out on top, but when we would start to cross over here, what we're going to do is hold the space bar down. And so you hold the space bar down, you notice this little via appears right here. So if you click, it'll set the via for you, which means you're now on the bottom of the board. Connection has been made between the top and the bottom, so you can draw across. You'll notice we're in blue again, so we're on the bottom. Then once again, press your space bar and draw across. And there you go, you made your connection. So this is a really useful tool. But once again, if you have a really fidgety analog trace, you're not going to want to use too many vias because it can just mess with your signal a little bit. Let me see, and there's also for the vias, if you like zoom in, there's also like sizes and stuff that you can adjust about them, and it can be a little bit fidgety to actually click on them, but we can worry about that at another time. So yeah, we've made our finalized PCB right now. So we've got one step left to do. Let me adjust real quick. And that step is our design rule check. You may notice that on the left, you don't see DRC anywhere, and that's because it's in the extended menu. And you're going to access that extended menu by clicking the little arrows in the bottom right here, and you'll see DRC. But actually, before I get into that, if anybody has any questions or is a little bit behind, just type it in the chat and we can help you out or wait a little bit. All right, there we go. Via again, certainly, yes. I guess I can just go over here then. Okay, back to route. Actually, I can just Command Z it. Okay, so we're going to want to start just on a trace. We can't get across right here, so just click the space bar, hold it down, and you'll see this via appears right there. Then if you click, it will set your via, and that will automatically put you onto the bottom of the board. And so I think you can just press the space bar again, and then set a via, you're back on the top, and draw across. So hopefully that's clear. If you have any more questions about that, then feel free to ask. It's a very useful feature of Eagle to get from one layer to another. All right, fantastic. So let's do our final step, which is our design rule check, and we'll see if any errors cropped up. Delete routing. Yeah, sure. That's the rip up button right here. It's right next to the routing button, and it has a little X over it. So you can just click rip up, and it will get rid of your routed trace. All righty. Let's see. Yes, not the same as delete. Yeah, you got to be very careful with delete too, because yeah, that's a good way to get rid of your air wires and then have forward backward annotation problems. So yes, make sure you use rip up when you mean to use rip up. And there are very few cases I think when you actually have to use delete on this on the PCB side of your board. Maybe if you don't want one of your polygons anymore, you can use it then. But most of the time, you are just going to be using rip up on this side because you don't want to have any annotation problems. All right, anywho, rip up or DRC. Yes, DRC is right here. So we're going to click on that. And a window pops up as you get more advanced into PCBs or as people give you specific requirements for your PCBs. These are all things that you might want to have to worry about. But for now, we're not going to get into any of those. We're just going to use the default checks that Eagle does for us. And all we have to do there is click the check button in the bottom right. And fantastic, as you can see in the bottom left right here, it says we have no errors. Let me see if I can actually create one now. If I click, I wonder if that'll create an error. Let's see. So let's run that DRC again. All right, great. So I created an error right there. And this is what it looks like when we have a wire stub. And they can be a lot smaller than this, actually. They can be so small that you actually don't see them until you get the error. So what you want to do to actually find it is you click on the wire stub right there. You click on it, and then you can see it's outlined in white right over here. So we can see exactly where it is. Now, how we get rid of wire stub error, I think you can imagine, is using that rip up button that we talked about before. So we're just going to click rip up on it. Now we can run our DRC again. And voila, we have 0 errors. So yeah, after you've done creating and routing your circuit like this, you always want to run the DRC to make sure that you didn't make any errors on it, as we've done here. So, and if anybody has any questions, feel free to go ahead and ask them now. I think we're done with the main tutorial part of it. It is optional, once again, to download all those libraries I have in the past, just so I had as much as possible available to me. But if you'd like to do it on a case-by-case basis, that is totally your prerogative. So any questions, put them in the chat. Otherwise, I will, all right, there we go.
What is the Gerber file? Can you show how to like generate the Gerber files? And
Okay, let's see if I remember how to do
basically,
that.
like when you want to actually order your PCB, you need to upload these Gerber files onto like that PCB website.
Yeah, so I think that
And that's
starts
how
with generate CAM data, if I recall correctly.
Yeah.
So yeah, you would click that, design change, yes, I'll save my design. All right, and so it'll create a zip file for you that has all of these in here, and that's all your different layers. And so as you get more into PCBs, you'll get a little bit more into modifying those layers if you want to, but that has all the information that you'll need, including the drill file and a whole bunch of other stuff. So that'll create a zip file for you with all that info. And once again, if you missed that, that was generate CAM data. Jackie, anything to add?
Oh, sorry. The drill distance error is probably when your wires are too close to each other, and like it will think that it's like do you think you can make a drill distance error?
One sec. This board thing. One second, the chat completely delete this board thing. Interesting.
Oh. You just want to delete your whole board?
Some microphones can make, yeah. So Jun saying leave, yes, the option clicking is a great way to do that. Otherwise, you're just going to be on the other grid. Kind of messed up the air wire. So, are you able to just Command Z or undo to get back to the state you were at before? So that's the way I do it. I just Command Z until I don't have that air wire issue anymore. Hopefully you can do that. Let me see, Jeffrey, definitely not your Eagle. Eagles, sorry, for Micromouse, a 2-layer board will definitely be what you're using. You won't have to get into 4-layer or more boards, probably until you start doing internships or more professional things like that. For instance, I think my brother is doing like a 4-layer board right now, and he's having a lot of fun with it. It's IEEE Lab. Unfortunately, the IEEE Lab does not have PCB manufacturing. There are actually a lot of pretty cheap ways to get PCBs though. And one of those ways is called PCB Way, as a matter of fact. And so you can put your Gerber files on there, get an estimate for it, and they'll ship them out to you for pretty cheap. The shipping tends to usually cost more than the actual PCBs themselves.
I think we have something in the lab just to like etch like a copper sheet, but it's like kind of jank and it's not like something you would like.
Yeah, I don't think it's something you can like put an Eagle file into. You just have to kind of do it yourself. But great, yeah, these are all great questions. Any other questions from people? Yeah, the Gerber file question was a very good one. Yeah, because we're not worrying about like the specifics of uploading it today. That'll be something that I think you're just gonna, like if you're a Micromouse or AP, you're just gonna end up sending your Gerber files to the leads, and then they'll worry about the manufacturing for them. But yeah, that's a good question.
Justin, do you still have that error? You can just type in like, okay, good.
Great. Let me see. And Eric, are you still having an AirWire issue? How to draw cool silkscreen designs. See, all right, fixed it. Great. Let's see. I think we got text option. I've never had good luck with text. Let me see if I can remember how to do this. PCB GK.
Oh yeah,
right there.
The layer is on the silk screen, not your top or bottom
Just
That's
like
right. That's right.
for those who will see, like if it looks like red like this, right now we're on the top layer, but you want to be on, I think T plate.
T-silk should be somewhere. Yeah, I think it's probably T-silk, right? So there's a bunch of different layers that you'll notice in the layers section up here. So we just talked about top and bottom already, but there's a lot of different layers. Sorry, go ahead. So yeah, I think it'd be on like T-silk, which is a silk screen is basically, it's just a fancy name for the layer on which like all the markings on the board are made. So like all these outlines you'll see are on the silk screen. So let me see if I can add them on the silk screen. Hopefully this is the correct layer. Hey, it is. All right, so yeah, that's a way to do it. You can click text right here, and on the silk screen layer, you can just type in whatever you want to, and then add it. And so in case people couldn't recognize it, this is a PCB.
I'm not sure about like the SVG into like on the silk screen, but I feel like you can. Oh yeah, you can. There's a way.
And Eric, and to your question, yes, you can shrink or make your polygon larger. Just click the move option and then click on a side of the polygon and then drag it.
Are there any other questions anybody has? All
right. If there aren't other questions, I think I'm going to stop my share. How do you get rid of naming of the routing? Naming of the routing. Click if you're stuck in like a naming mode, you can always click escape or click like the move option or something like that. But all right, so in that case, thank you so much everybody for coming out to our workshop. We were so happy to have you here. I hope you learned a lot. This is a really fun, cool skill that you're going to be using a lot in your engineering careers going forward. Jackie, anything else to say?
No, just congratulations on making your guys' first PCB, and hope to see you guys at the next workshop.